A very good evening to you, boys and girls. First of all, I take the opportunity to congratulate all of you. It's a big achievement. पहला सर्टिफिकेट आया आपकी फाइल के में, इतनी मोटी हो जाएगी ये फाइल. By God's grace and good wishes of your teachers and parents and your hard work, which is the most important, this file will keep growing. It is the first certificate in your file and you have achieved it beautifully. As I said in my message, let's be prepared for the next adventure, and we are already on track. In true sense, now you can call yourself in 10+1, and it's going to be online. All the best. Come on, boys and girls. Now, what we have done in physics up to now is सब कुछ नया था. कभी डिफरेंशियल आ गया, इंटीग्रल आ गया, डायमेंशंस आ गई, प्रोजेक्टाइल मोशन आ गया, वेक्टर्स आ गया. Everything was new to you. Now we are suddenly going to take you back into your class 9th. As बोर्ड पे एक्चुअली मैंने लेक्चर स्टार्ट किया था, बीच में फोन आ गया. आई हैव टू रिपीट द एंटायर थिंग. अब मैंने एरोप्लेन मोड पे कर दिया. सो एज आई सेड, Newton's law of motion, we fondly call it NLM. Whatever we have done in your class 9, everything will be repeated in a slightly elevated form, higher form. Questions will be based on vectors and differential calculus. Let's see. The theory part is going to be really very simple. एक बार register में लिख लिया, that's it. You have to clearly follow the conceptual questions, the short answers, and your numerical problems. That is going to be asked in the paper. Now, what is the force? A force, it is a push or a pull which changes or tends to change the state of rest or of uniform motion along a straight line. It is also required to change the direction of the body. This means that the force is required to change the state of rest. That if a body is at rest, it is the force which will be required to move it, or of uniform motion along a straight line. If a body is in motion and you have to stop it, you have to apply a force. If a body is in motion and is moving with uniform speed along a straight line, you have to increase or decrease the speed, you will have to apply a force. And even if the speed remains constant, but you have to take a circular path with the same speed, still you will have to apply a force. Thus, can you think of one word which is happening in all the three things? Acceleration. It means that it is an external agent which produces acceleration. It is an external agent which produces acceleration. Acceleration means change in velocity. And the change in velocity can happen in three ways. By changing speed only, by changing direction only, and by a change in both speed and direction. It is an external agent which produces acceleration or change in velocity. Whether a body is at rest and begins to move, or if it is moving and it comes to rest, or it changes direction only. In all these cases, there is a change in velocity. And in change in velocity means acceleration. Thus, whenever there is an acceleration, there is going to be a force must be required. Right? Let us move forward and define something called momentum. In the class, मेरी ये आदत है कि मैं पूछता था कि मोमेंटम क्या होता है. आई एम हैविंग ऑमलेट, शाम के 5 बजे हैं, दिस माय स्नैक. And there were so many hands going up and telling me, sir, it is mass into velocity. No doubt, yeah, it is mass into velocity, but what is momentum? It is the quantity of motion present in a body. It is the quantity of motion present in a body and is equal to the product of its mass, product of the mass and its velocity. Quantity of motion present in the body. P. अब वेक्टर बढ़ गया ऊपर. Mass is the scalar, velocity. Momentum, mass is the velocity. kg meter per second or gram centimeter per second, and dimensions are m lt minus 1. ये आ गया जी मोमेंटम. जस्ट इमेजिन, मैं आपको कुछ याद कराता हूँ, कुछ बताता हूँ कि what is momentum. You know, just imagine that if you have a scooter and a bus moving with the same speed, obviously the bus has more momentum. Or why not say a train? A train and a scooter are moving with the same speed, but the train का mass बहुत ज़्यादा, ठीक है, उसका momentum बहुत ज़्यादा. एक रोड रोलर है, उसकी स्पीड बहुत कम है, 0.5 मीटर पर सेकेंड. एक बाइसिकल है, उसकी स्पीड है 10 मीटर पर सेकेंड. मोमेंटम तो उसका ज्यादा है ना. सो व्हेन वी से मोशन, प्लीज सी दैट इट डज नॉट ओनली मीन स्पीड, इट इज अ प्रोडक्ट ऑफ द मास एंड इट्स वेलोसिटी. दिस इज अबाउट मोमेंटम. आज मैंने एक खास जगह तक खत्म करना है और आपको न्यूमेरिकल देने करने हैं. साइमल्टेनियसली चलाऊंगा. सिंपल है थ्योरी सर. Let me talk about maybe China. Inertia. पहले भी पढ़ा हुआ आपने. The inability of a body, या उल्टा कर देते हैं. The property of a body due to which it continues its state of rest or of uniform motion along a straight line. तीन तरह का है. Inertia of rest, inertia of motion, and inertia of direction. डायरेक्शनल इनर्शिया भी बोल देते हैं इसको डायरेक्शनल इनर्शिया भी बोल देते हैं. आई एम गोइंग टू गिव यू अ फ्यू एग्जांपल्स जो आप अपने रजिस्टर में अपने आप लिख लोगे फ्रॉम द बुक, और आई विल क्लिक अ पिक्चर मैं डिस्कस कर रहा हूं इनर्शिया ऑफ रेस्ट। बहुत एग्जांपल्स आपको भी पता होंगे, लाइक स्कूटर, मोटरसाइकिल, even in a car, train, bus. You are in a state of rest. You are sitting there, the bus is also in a state of rest. Suddenly the bus begins to move and you experience a backward jerk. What you experience a backward jerk is because the lower part of the body, your legs, are in contact with the bus. जब ही बस आगे मूव होना शुरू होती है, the lower part of the body moves along with the bus, but the upper part of the body remains behind because it wants to continue its state of rest. So basically you don't experience a backward jerk, it appears to you. Actually the lower part of your body moves along with the bus and the upper part of the body wishes to continue its state of rest. और देख सकते हो, you have a coin placed over a cardboard, ठीक है, and you have a glass tumbler, खाली है जो, तो गत्ते को अगर एकदम से खींचोगे तो वो खींचा जाएगा, the coin will fall inside the tumbler because the coin is in a state of rest, it wishes to continue its state of rest. You pulled the cardboard, it got pulled, the coin fell down due to gravity. There is another very interesting example that I always say here. There is some fruit on the tree. There is some fruit on the tree. ब्रांच को आप हिलाते हो और फ्रूट नीचे गिर जाता है. You have to tell me, did the branch leave the fruit or did the fruit leave the branch? I repeat, did the branch leave the fruit or did the fruit leave the branch? आप कहोगे सर एक ही बात है. नहीं. The branch and the fruit both were initially in a state of rest. फिर आपने क्या किया? ब्रांच को पुश किया. जब आपने ब्रांच को पुश किया तो फोर्स ब्रांच के ऊपर लगी. The fruit was in a state of rest. It continued its state of rest and it fell down due to gravity. Be sure about it, and it fell down due to gravity. Now, inertia of motion. Seat belt. Seat belt, जनाब seat belt क्यों पहनते हो? Your car is moving at a rate of 80 kilometers per hour, 60 kilometers per hour, 100 kilometers per hour भी होती है हाईवे पे. And suddenly you apply the brakes. You are pushed forward because your body, which was in a state of motion at the same rate as that of the car, the lower part of the body came to rest along with the vehicle. आपने ब्रेक लगा दी, ठीक है? The upper part of the body continues in motion. Just imagine you are moving at the rate of 100 kilometers per hour, crash, and that is why you are supposed to wear a seat belt. बंदे कहते हैं पता नहीं यार सीट बेल्ट क्यों पहनी, मैं क्या डरता है? यार डरने की बात नहीं है. And that is why these days, in the eventuality of an accident, your vehicle will come to rest quickly. So what happens is there is a bubble inside. The bubble will come out on the dashboard and you would hit the bubble and hopefully you are safe. But primarily, please see that you must wear a seat belt. And remember, if you are not wearing the seat belt, the bubble will not come up. Your seat belt is a switch for the bubble. Be sure that you wear a seat belt. ट्रेन में बैठे हो, गाड़ी रुक जाती है, you experience a forward jerk and so on. Inertia of direction. Inertia of direction means कि कोई भी चीज अपने आप डायरेक्शन नहीं बदल सकती. You will have to exert a force. There will be some external agent which helps it make it move in a circular path, even without a change in its speed, because there is change in direction. You must have seen that if you are whirling a string, गोल 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 घुमा रहे हो, जब ही रोका, जिस जगह पे रोकोगे, it will go along the tangent, because the tangent is the direction of velocity at that instant and it will go along the tangent. आप उसको घुमा रहे थे. You produced a tension in the string and that is why it was moving. The moment you stop it, it will move from the place you stopped applying the force. At that instant, it will move along the tangent. You must have seen knife तेज करते हुए, there is a circle which is moving and the knife is placed over there. The sparks are flying tangentially. टायर, साइकिल का टायर जब पानी में से निकलता है तो जो मड है वो उठाता है या कोई अपना पानी उठाता है तो वो along the tangent जाते हैं. That is why wheel के पीछे एक चीज लगी होती है जिसको बोलते हैं मड गार्ड. यार मड गार्ड ऐसे बोल देते हैं. It's basically a mud guard because the mud which will be lifted or the water which will be lifted by the wheel will fly along the tangent and the mud guard is strategically placed. Be sure that these examples are written. 5 6 examples मैं आपको दे दूंगा. 3 4 लिख लेना. Just a minute. I just want to have a glass of water. Mandeep. I'm back, boys and girls. Now, ये आपके inertia के examples हो गए. Now we have laws. ये सारा कुछ आज फटाफट कर लेना, बहुत आसान है. Newton's first law. इन टॉपिक्स के न्यूमेरिकली करने आपने तरह न्यूटन्स फर्स्ट लॉ लिख लो. एवरीबडी कंटिन्यू द स्टेट ऑफ रेस्ट और ऑफ यूनिफॉर्म मोशन अलोंग अ स्ट्रेट लाइन अनलेस एन एक्सटर्नल फोर्स एक्ट्स. ठीक है, इनर्शिया की डेफिनेशन ही है. ठीक है, पर अब क्या हो गया? आई रिपीट, मैं लिखूंगा नहीं, अपने आप लिख लेना. एवरीबडी कंटिन्यू द स्टेट ऑफ रेस्ट or of uniform motion along a straight line unless an external force acts on it. This is also called the law of inertia. बिल्कुल सेम है. ये every object continued state of rest or of uniform motion along a straight line unless an external force acts on it. Unless an external force acts on it. This is Newton's first law. Newton's second law. The rate of change of momentum is directly proportional to the impressed force. And will act along the direction of the force. ये कुछ आपने किया था 9th क्लास में भी किया हुआ। हम सिर्फ इसको वेक्टर फॉर्म में इंटरप्रेट करेंगे। The rate of change of momentum is directly proportional to the impressed force and will act along the direction of the force. ध्यान से सुनना। F is directly proportional to rate of change of momentum. आ गया जी, आ गया। ठीक है, देखो कैसे लिखा है। This is the mathematical way of expressing the second term. F is proportional to d by dt of m into v. V is velocity. F is directly mass is a constant. बाहर आ जाए। d by dt of v. F is proportional to m into a. As rate of change of velocity is acceleration. Proportionality हटाया k into m into a. The units are so chosen that k is equal to 1. Therefore, f is equal to m into a. This is the mathematical expression of Newton's second law. Right? F is equal to m into a. अच्छा, यहां से फिर लेते हैं again from f is equal to d by dt of m into v. If v is constant, if v is fixed, तो f is equal to scalar form में v into dm by dt. Just like in the case of a balloon or a rocket, एक balloon में हवा भरी हुई है, ठीक है? And v is the speed with which air moves out of the balloon, and dm by dt is the mass which flows out per second. So f is equal to v dm by dt can also be used. Generally अभी मैं यही use करूँगा. If m is a constant, तो f is equal to ma is valid. If v is a constant, तो v dm by dt is valid. It means that more important is f is proportional to d by dt of v. This is the most general form, and not f is equal to ma. This is the special case if m is constant. किसी को सर m constant ही होता है, मैंने आपको एग्जाम्पल दिया तो है. वैसे मास constant नहीं होता. क्लासिकल मैकेनिक्स में हम कांस्टेंट मानते हैं, बट इन रिलेटिविस्टिक मैकेनिक्स व्हाट वी हैव इज दैट मास वेरीज विद स्पीड. पढ़ाऊंगा अभी इसी तरह चलने दो. ओके, नाउ वी हैव न्यूटन्स थर्ड लॉ. न्यूटन्स थर्ड लॉ सेज दैट टू एवरी एक्शन देयर इज एन इक्वल एंड एन ऑपोजिट रिएक्शन. Newton's third law. To every action there is an equal and an opposite reaction. Let's say we have a table and we have a block placed there. This is the weight mg and this is the reaction R. In this case, you know, mg is the action on the table. M into G. Action R. Reaction on the block. Remember, action and reaction forces can never cancel each other. Why? Because they are not acting on the same object. कैंसिल का तो सवाल ही नहीं उठता. हाँ, they balance each other एक अलग बात है. Cancellation की बात तो हो if they are acting on the same object. Here, action and reaction do not act on the same. Action and reaction forces can never cancel each other as they are not acting on the same body. Actually, action and reaction forces will always balance each other. एक थोड़ी सी चीज रह गई, that is the units of force. From F is equal to m into a. तो फोर्स के यूनिट्स आगे बैठेगी kg मीटर पर सेकंड स्क्वायर, जिसको हमने बोल दिया 1 न्यूटन, या आ गया ग्राम सेंटीमीटर पर सेकंड स्क्वायर, जिसको हमने बोल दिया 1 टाइम. Now 1 न्यूटन is 10 raised to power 5 टाइम. It can be calculated by N1 U1 is equal to N2 U2. There is also a gravitational unit of force. Gravitational unit of force, which is 1 kg weight. This is the force acting due to a mass of 1 kg. Right? That is the force due to its own weight. 1 kgf. 1 kg into 9.8 meter per second square, which is 9.8 Newton. Similarly, 1 gram force will be 1 gram into 980 centimeter per second square, which would be 980 dyne. Remember, there was a question in vectors जहाँ resolve करना था, उसने कहा था there is a force of 1 kg weight, 1 gram weight, या पता नहीं 5 gram weight, तो उसको 5 into 980 लेके करते हैं. Gram weight is the unit of force in which this is the conversion into SI and this is the conversion into CGS. I think I have finished the part that I wanted to do today with you. Let me see how much time do I have. इतना सा ही होता है. I think I could discuss a few numerical problems with you. We are just around 30 minutes into the lecture. I can spend some time with you today, and let me remind you a few things. is now, जो भी कुछ न्यूमेरिकल करने हैं वेक्टोरली करने हैं. Let me give you a small reminder. डिस्कस करते हैं आपस में. Two forces acting together on an object, P vector and Q vector. R vector is P vector and Q vector. लिखना प्लस है. F1 वेक्टर एंड F2 वेक्टर. इसमें से वैल्यू कितनी है नहीं पता लगता बिल्कुल. ये पता लगता है कि नेट फोर्स एक्टिंग ऑन दिस ऑब्जेक्ट इज द वेक्टर सम ऑफ द फोर्सेस एक्टिंग ऑन द बॉडी. दैट इज ऑल. If these two forces are acting along the same line, then its value is P plus Q. एक 8 है, एक 6 है, net 14 हो गई. If they are acting in the opposite directions, P minus Q. If they are acting perpendicular to each other, square some root. Net force की वैल्यू इस तरह निकालनी पड़ेगी. If the two forces are equal in magnitude, and the angle between them is 120 degrees, then the value of the resultant is equal to the value of either of the forces. I hope you remember. Now, and if there are two forces acting at different angles, that is the angle between the forces is between 0 and 180, then the value of the force is given by P square plus Q square plus 2PQ cos theta, where theta is the angle between the two forces, and the angle between the two forces is going to be the angle when these forces are placed co-initially. When these forces are placed co-initially, right? Then जो यहाँ पे बहुत यूज हो रहा है वो यूज होना बेटा ये सब्ट्रैक्शन ऑफ वेक्टर्स. जैसे वो बोलेगा फाइनल मोमेंटम माइनस इनिशियल मोमेंटम, तो वो वेक्टोरली करना पड़ेगा हमें. वी विल फाइंड द रिजल्टेंट ऑफ P2 वेक्टर एंड माइनस P1 वेक्टर. देखो P2 वेक्टर और P1 वेक्टर का रिजल्टेंट दो, बट वी आर इंटरेस्टेड फाइनल मोमेंटम एज अ वेक्टर minus initial momentum as a vector. Let me form a concept. Let me have a question here from the book. It is the very first example. It is the very first example, please. He says a ball is moving with a momentum of 5 kg meters per second. ये एक ball है, and a ball is moving with a momentum of 5 kg meters per second. P1 वेक्टर का मैग्नीट्यूड है 5 kg meter per second. A ball is moving with a momentum of 5 kg meter per second and strikes against a wall at an angle of 45 and is deflected at the same angle. It strikes at an angle of 45 and is deflected at the same angle. Calculate the change in momentum. This is P2 vector and this is the same angle. This is equal to P2 vector. Find change in momentum का magnitude. आ गया ना वेक्टर? आ गया ना वेक्टर? Now, यहाँ पे we will have to determine the resultant of P2 and minus P1. What I say is that एक डायग्राम दोबारा बनाता हूँ मैं, बुक में थोड़ी और कर किया हुआ. This is P2. And this is minus P1. Right? And this angle is 90. अब बोलोगे वहां भी 90 था यार, इंसिडेंटली आ गया ना, इंसिडेंटली आ गया. This angle is 90, but this angle is not the angle between P1 and P2. वो भी 90 आ जाएगा, वो भी 90 आएगा. क्योंकि अगर मैं P2 को उठा के यहाँ रखूंगा या P वो भी 90 आ जाएगा, बट आई एम इंटरेस्टेड इन द एंगल बिटवीन P2 एंड माइनस P1. दिस इज एक्चुअली द एंगल बिटवीन P2 एंड माइनस P1. दोनों ही 90 मैं मानता हूं, पर एंगल ये एंगल P1 और P2 में नहीं है, ये एंगल P2 और माइनस P1 है. नाउ change in momentum is P2 vector minus P1. This is the resultant of P2 and minus P1. Delta P का magnitude. Vectors is most important. P2 के magnitude का square 5 का square. Minus P1 का magnitude. जनाब माइनस P1 का मैग्नीट्यूड -5 नहीं है, मैग्नीट्यूड उतना ही है, मैग्नीट्यूड 5 है, उसका स्क्वायर 5 का प्लस 2 इंटू P1 इंटू P2 इंटू cos 90 0 स्क्वायर सब रूट आ गया. देयरफॉर डेल्टा P का मैग्नीट्यूड कितना है जी 5√2 kg मीटर पर सेकेंड. मेरे जैसा एग्जामिनर सवाल पूछ लेगा, can the change in momentum be more than the magnitude of the momentum? Yes, why not? आपके सामने ये भी initial momentum 5, final momentum 5, डायरेक्शन बदल गई. चेंज इन मोमेंटम कितना 5√2 which is more than 5. वेरी नाइस, वेरी वेरी क्लियर. डायरेक्शन क्या है इसकी? डायरेक्शन ये फोर्स की. उसने पूछी नहीं इस क्वेश्चन में, पर पूछ सकता है. द डायरेक्शन इज नॉर्मल टू द बॉल. जो चेंज इन मोमेंटम की डायरेक्शन है वही फोर्स की डायरेक्शन है. दिस वाज एग्जांपल 1. ये देखो सवाल आ गया एग्जांपल 3, राइट? एनसीईआरटी क्वेश्चंस हैं सारे ये. ही सेज अ balloon has a mass of 5 gram in air. This was example 1. Example 3. Example 2 आप अपने आप करना. A balloon has a mass of 5 gram in air. ठीक है? The air escapes at a uniform rate with a velocity of 4 centimeter per second. 4 centimeter per second. Escapes. Air escapes at this rate. ठीक है? Air escapes at this rate in 2.5 seconds. Find the force of the balloon. Remember, F is equal to V into dm by dt. V कितना है? 4 centimeter per second. It means 4/100. Right? चलो दाइन में आ जाएगी, दाइन में आ जाएगी. चलो दाइन में आ जाएगी. ठीक है? 4 centimeter per second into dm by dt क्या है? 5 gram mass in 2.5 seconds. Thus it is 8 dyne. The force is 8 dyne. इसीलिए मैंने आपको थ्योरी में वो करवा दिया v dm by dt. इसीलिए थ्योरी आती है कि हम न्यूमेरिकल कर सकें और शॉर्ट आंसर क्वेश्चंस कर सकें. Fourth question you will be able to do. Fifth question, I'll just read it out to you. ठीक है? He says the constant retarding force of 50 newtons is applied to a body of mass 20 kg, moving initially with a speed of 15 meter per second. How long does the body take to stop? लो मैं कर ही देता हूँ. छोटे छोटे क्वेश्चंस हैं. He says in the question that a body is moving with a speed of 20 kg मास है और स्पीड उसकी 15 मीटर पर सेकेंड. मास 20 kg, speed 15 meter per second. The final velocity is supposed to be 0. And he says that a retarding force of 50 newtons acts on the object. पूछा गया है टाइम टेकन टू स्टॉप। जनाब पहले तो रिटार्डेशन निकालो आप, -58 f ओवर -2.5 मीटर पर सेकेंड इज द एक्सेलरेशन, रिटार्डेशन। तो v इक्वल टू u प्लस at लगा लो। v कितना है 0, u कितना है 15, a कितना है -2.5 और t कितना है आपने निकाला। तो a आसान छोटे छोटे क्वेश्चंस हैं ये आज आपको करने को चाहिए। Similar question would be that there is a mass of 3 kg and it changes its speed from 2 meters per second to 3.5 meter per second in 25 seconds। तो यहाँ से आप एक्सेलरेशन निकाल लोगे, फाइनल वेलोसिटी है आपके पास, इनिशियल वेलोसिटी है आपके पास और टाइम दिया हुआ है और उसने फोर्स पूछी है, 3 kg का मास है, यू विल मल्टीप्लाई बाय इट। ओके, ये सारे क्वेश्चन बड़े आसान से हैं टोटली। ओके, एग्जाम्पल 11th है, एग्जाम्पल 11th है विच आई एम गोइंग टू डिस्कस विद यू। NCERT है। He says that there is a body of mass 5 kg and is acted upon by 2 perpendicular forces of 8 Newton and 6 Newton। ठीक है, 2 फोर्सेस लगेंगे, एक 8 न्यूटन की एक 6 न्यूटन की और दोनों आपस में परपेंडिकुलर। फाइंड द मैग्नीट्यूड एंड डायरेक्शन ऑफ द एक्सेलरेशन। ये आपके पास एक बॉडी, ये 8 न्यूटन की फोर्स लगी है और ये एक 6 न्यूटन की फोर्स लगी है। दिस इज द रिजल्ट। Our vector is F1 and F2 and R has a magnitude of F1 square plus F2 square under the root and R is a 8 square at 10 Newton। और मास कितना है ऑब्जेक्ट का? ऑब्जेक्ट का मास है 5 kg। Therefore the acceleration is resultant force F लिख लो, F ठीक है, F ओवर है। It appears there is a single force of 10 newtons। देखा वेक्टर का फायदा। अब जिसने नहीं किया होगा मैं कुछ कर नहीं सकता। There were students who were willing to join yesterday, you know, I refused। कैसे हो सकता है? दोबारा आप वेक्टर नहीं बढ़ा सकता था। आपको थोड़ा डाउट है, आप पूछ सकते हो। 10/5 which is 2 meters per second। डायरेक्शन ये एंगल अल्फा, tan अल्फा कितना आ गया जी 6/8 और which is 3/4। ऑथर पता नहीं कैसे कर रहे हैं। 3/4 0.75 which is 36 degrees and 9 minutes। Alpha is 36 degrees and 9 minutes with 8 Newton force। बड़े छोटे छोटे सवाल हैं, वेक्टर्स के साथ ही ज्यादा काम किया जाएगा। सो बॉयज एंड गर्ल्स, आई विल गिव यू कल ही कराऊंगा मैं बाकी सारे क्वेश्चंस, यू नो, इक्विलिब्रियम के क्वेश्चंस भी करवाता हूँ, टेंशन वाले पहले पढ़ाऊंगा। लेट्स सी व्हाट वी डिस्कस टुमारो। ओके, please see that we have started with something really nice, very interesting। थ्योरी आपने की हुई है, शॉर्ट आंसर और न्यूमेरिकल्स अच्छी तरह करने हैं। जितनी थ्योरी आपने रीड करनी है मैंने आपको लिखवा दी। बाय बाय।